A linear loaded dipole is a type of shortened antenna where a portion of the radiating element is folded back on itself to create a shortened transmission line stub. This fold adds the necessary inductive reactance to electrically lengthen the antenna without requiring the massive physical footprint of a full-size half-wave dipole. If you are trying to make an existing 80-meter dipole resonate on the 160-meter band without increasing its total physical length or shifting the feed point, linear loading is arguably the most efficient way to achieve it. When you fold the wire back parallel to the main element, the parallel section acts like a shortened transmission line stub rather than a pure radiator. This stub introduces inductance to the antenna system. Unlike a traditional loading coil, which concentrates the inductance in one localized spot, linear loading distributes this inductance along a section of the antenna. For homebrewing antennas, especially when running external power like linear amplifier, linear loading offers distinct advantages over traditional base or center loading coils. Efficiency Q factor high for linear loading, lower resistive losses because the inductance is created by continuous thick antenna wire. For coil that is inductive loading, it is lower. Coils introduce resistive losses which turn your RF output into heat. Bandwidth broader for linear loading, maintains a slightly wider usable SWR curve across the band. Narrow for coil loading. High Q coils create a sharp resonance, often requiring a tuner for small frequency shifts. Power handling is excellent for linear loading, handled entirely by the wire gauge. No risk of arcing between tight coil windings. Power handling is limited for coils. Coils can overheat, melt, or arc if not heavily built for the amplifier's output. Construction is mechanically complex for linear loading, requires a rigid spreaders like PVC conduit to keep the wires parallel